varies directly with one another. What I meant to do was this, directly with the other. And notice that the words used were per. Whenever you have the word per, that's telling you it's varying directly with something else. So quantities described by a proportional relationship are represented by a linear equation in the form of y equals mx plus b, or y equals mx for right now, where m is the slope of the line that passes through the origin. The origin of any graph is 0, 0. So it's not in quadrant 1, 2, 3, or 4. It's right in the very middle where the where the lines meet, where the x-axis and the y-axis meet. And if all 4 quadrants are shown, that's the very middle of the plus sign. The slope of the graph, actually, I want to draw that out for you just so you have a visual. Oh, where is it? That very middle part. I did not draw it very well, but you get the idea. The very, very middle is the origin. So the slope of the graph of a linear equation is a measure of the rate of change of one variable with respect to another variable, and is defined by the ratio of the rise of the graph compared to the run. So rise over run. It does matter. If you have a negative number, it totally matters. So in this first example, I went up 1, 2, 3, and over 1, 2, 3, 4. That is 3/4. That would be the slope. If I did it this way, where I go down 1, 2, 3, down is negative, and then I go over 1, 2, 3, 4 to the left, -4. Remember, when you have sleeping dog, when you have 2 negatives, your sign is positive. So -3 over -4 equals 3/4. So either way you do it, you get 3/4. Just the way I did it, going up and over, you didn't have to deal with any negative numbers. So be careful of that. Trying to use my pen tool is my finger and it didn't work. These little guys right here are called subscripts. Subscripts, it just tells you how many, like what number or how many. It's not an exponent at all. We're not doing any math with it. It just means the first x point and the first y point and the second x point and the second y point. All right, that's all it's telling you. You're not multiplying or doing anything like that. The slope is the ratio of the change in the y values of the points. The y values are the rise to the change in the corresponding x values. The x values are the run. So your slope formula is y2 minus y1 over x2 minus x1. All right, and we are going to be practicing how to use that in just a second. You guys used it last year, but again, we're going to do some practice so you feel really comfortable with it. So the first step in calculating the slope of a line is to pick 2 points on the line and label them as your x1 and your y1 and your x2 and your y2. Then the rate of change can be found by applying the slope formula. You do have to memorize this. So please make sure you know this. Rise over run equals y2 minus y1 over x2 minus x1. And always reduce any fractions to ensure that the slope is in its simplest form. So let's practice. In the following graph, notice that 2 easily identifiable points are 4, 3 and 8, 6. All right, so 4, 3, we're going to label always x1, y1, whoops, and then x2, y2. Okay, so then what you do is you go over to your slope formula and you plug your points in. So let's see, our first one is y2. I always cross off. y2 is 6, right here, minus y1. y1 is 3, so that's where 3 comes in, over x2, which is 8, minus x1, which is 4. So we have 6 minus 3 equals 3, and 8 minus 4 equals 4. So the given line has a rise of 3 units and a run of 4 units. Therefore, the slope of the line is 3/4. Note that if the assignment was switched in this example, the result would still be the same. For example, if we let x1, y1 be 8, 6, and we let x2, y2 be 4, 3, it would still equal 3/4. So it doesn't matter which pair of points you put as x1, y1, as long as you pick two pairs of points on a line and you use the slope formula correctly. So although it doesn't matter, it is important to make sure that the order in which the variables are subtracted remains the same in the numerator and the denominator. All right, so in other words, if you had y2 over y1 over x2 minus x1 equaling y1 minus y2, the slope would not yield the same slope. You can flip the points, but you cannot do point 1 first. You got to do the second point minus the first point always. So the slope of an equation that describes a proportional relationship is also known as the unit rate, or the rate per one given unit. The calculation of slope can be extended beyond proportional relationships to that of linear equations in the form y equals mx plus b. Again, where b, whoa, that was some terrible circling, where b is the y-intercept. Here we have he charges 16 per hour. When you have the per hour, that's always your slope. That is always your mx. The what you don't know, like the hour, is your x, or you could put 16h. And then your anytime you have a plus or an initial value of something that doesn't change, that stays the same, it is your y-intercept. So we have 16 per hour plus the charge that doesn't change. No matter how many hours he works, there is a $25 house call fee. So that is a constant. The 16x, that's a factor. So let's plug in some values, some number of hours. Again, we're not going to use negatives for this because you're not going to work a negative hour. So you have to look to your example to see what kinds of numbers would make sense to plug in. In this case, 1, 2, 3, 4, 5, 6. Like, start simple. Don't pick huge numbers. Okay, so if we plug in 1, number of hour, remember x equals hours and y is the cost. So here's our value of x we're plugging in each time. So when hours equals 1, 16 times 1 is 16. 16 plus 25 is 41. That means the cost would be $41 for 1 hour of work. For 2 hours of work, it's 16 times 2 plus 25. It would be $57. Let's jump all the way down to 6 hours of work. 16 times 6 hours plus 25 is $121. So then we're going to graph it using your table of values. And then we're going to let x represent the number of hours and y represent the cost in dollars. Almost always x represents time. And I say almost always because there's some examples that x does not represent time. And I'll go over those in the lesson with you guys. I'm just coming back here to check and see what they used for this, what this example used. So we've got x1, y1 as 1 and 41, and we've got x2, y2 is 2 and 57. All right, so we've got y2 minus y1 over x2 minus x1. So we got 41, 57, 1, and 2. So we've got 57 minus 41, which is 16, and 2 minus 1, which is 1. 16 over 1, simplified, is 16. So the slope is 16, or $16 per hour. This verifies the given information in the problem that each hour of work does cost $16. So last, how can the slope be used to determine how many hours of work a customer could get for $150? So the number of hours of work that would cost $150 can be estimated from the graphed values. So you would find 150 on the y-axis and then look to the right to determine the corresponding x-coordinate. Let's do that. So we would go up to 150 right here, and we would go all the way over to see if we extended our line, where would it hit? And then we'd go down. Whoops, we'd go down and look. It's about 7, in 3/4 hours of work. So it's a little less than 8 hours. And so using the rate of $16 per hour, the number of hours can also be found by plugging it into the formula. So we could do 150 equals 16x plus 25. And we can solve for x by subtracting 25 from both sides. That cancels. 16x comes down. And then we subtract 125 equals 16x. I'm going to erase this. So we have 125 equals 16x. Then we divide by 16. So then we have x equals $7.81. I mean, not dollars, 7 hours, 7.81 hours. So that is a little more than 7 hours, 7 3/4 hours, a little less than 8 hours.